In this video lecture, we're going to discuss data encoding. If say data encoding, we're going to convert data, numbers, characters into binary using a certain pattern or using a certain rule. Okay, so we convert characters, numbers into binary using rules. Okay, so now the question when we transform, when we convert, when we represent this data using binary is how many binary digits needed to represent our data. Will it be 1 bit, 2 bits, 10 bits, 16 bits, or etc.? Okay, so how we're going to determine the number of bits for our data set? Later, we're going to answer it. Okay, so what will be the consideration in determining the number of bits to represent a set of data? Okay, so let's discuss binary code first. So again, one binary digit, we call it 1 bit. Binary digit is bit, okay? And it could represent two values. 0 represent a certain character, 1 another character, okay? So another example, 0 could represent hot, 1 could represent cold, or 0 could represent false, 1 represent true. Or if we're talking about switch, 0 represent off and 1 represent on. And if we're going to increase the number of binary digits, okay, so for example, 2 bits, so it means we could represent more data, okay, in a set. So if we have 2 bits, we could represent 4 distinct values. So for example, about temperature, 00 represent hot, 01 represent warm, 10 represent cool, and 11 represent cold. But in case if we're going to increase from 2 to 3 binary digits, so how many possible values can we represent? It is 8 values. Okay? So for example, 000 represent black, 001 represent red, 010 represent pink, 011 represents yellow, 100 represent brown, 101 represents blue, 110 represent green, 111 represents white. So as you can see here, as you increase the number of digits of binary digit, you can represent lots of data. You also increase the number of values that can be represented. So there is a direct correlation between the digits, the binary digits, the number of binary digits to the number of values that it could represent. Okay? And also in binary code, we don't duplicate or we don't use the same pattern to represent different values. Okay? It should be one pattern, one value. No repetition of pattern. Why? Because there will be problems when we code it, when we transform it to original value, there will be error. So for example, if we're going to use 000 to represent black and red, so it's easy. When we input black, it will be represented by 000. But in case we're going to retrieve 000, what will be the value? Will it be black or red? So that's why we need to have a distinct value for each value, distinct pattern for each value. Okay? Don't forget that. So why do we need to code binary numbers using binary patterns? One is flexibility of representation. So it's easier to transform numbers using binary coding. Okay. And also, using binary coding, you could represent different types of data. Will it be numeric or non-numeric? Okay. And we just know the pattern. It's easier to transform into binary. Okay. Well, if we're going to use the binary equivalent of decimal, definitely you're going to do arithmetic operation, division, then then ordering of values. So it will take time. While in binary coding, numerical values, pattern, binary. That's it. That's how it is, how easy the number can be transformed into binary using binary code. Just using pattern, we have the binary equivalent. Okay. So this is an example of non-numeric binary code, wherein binary number represent a value, which is the color. So each color is represented by a distinct pattern. Okay. And there are instances, there are some pattern that is not or not used because we lack the values and the pattern is more than the values that we're going to represent by the pattern. That's okay. Okay. So it's better to have more patterns compared with the values to be represented rather than we have lack of patterns. We have less than the number of patterns compared with the values that we're going to represent. Okay. It means there are some values that could not be represented if we lack patterns. So it is better to have more patterns, okay, compared with the values rather than less pattern compared with the values. Okay, so this is the formula to be used to determine the number of bits. So m less than r raised to n, where m is the number of elements. Actually, this is less than or equal to. M is the number of elements to be represented. So in a set, how many elements do we have? Okay, so that will be m. While r raised to n, okay, so r means radix, n is the exponent. The exponent represents the number of bits. So for example, so for elements, we're going to represent it by binary. So what will be the value of n that would represent, that would be, that will determine, that will satisfy m less than r raised to n. So the minimum value is 2. 4 less than or equal to 2 raised to 2 is 4. So 2 digits, 2 bits is enough to represent 4. Okay, but if we could also increase it to 3 to 4, no problem. Okay, the rule here is the minimum is the 2 digits. Okay, but when we create our own pattern, definitely to optimize, to have to have lesser loss, okay, to have lesser number of patterns that is not used, it's better to use the minimum value of n. Okay, minimum value of n to represent our elements. So between 2 and 4, we need to choose 2 because it's enough. Okay, we don't need lots of pattern because it's just waste pattern if we're going to increase the number of digits. So if we want to lessen the not use pattern, it's better to use the minimum value of n. That would make this statement true. Again, this should be less than or equal. Okay. So we have two types of binary code for decimal digits. We have weighted code and non-weighted code. If say weighted code, the position of the pattern has weight. So for example, we're going to use 4 bits to represent one digit, one decimal digit. So we could use 8421. So it means the first position has a weight of 1, second position 2, 4, and fourth position is 8. And we could also have a negative position like -2 and -1. Okay? While non-weighted means there is no pattern. There is a pattern, but there is no positional value. So we have rules to determine the pattern that would represent our digit. Okay, so these are some examples of binary code for decimal digit. So again, 8421, we use 4 bits to represent one decimal digit. So again, 8421 is the weight of each position. So that's why if we are going to code 2, 2 will be equivalent to 1, and the rest will be 0. 5, so which value we're going to add? 4 and 1. So that's why 1, 1, and the rest will be 0. How about excess 3? Basically, it's based on 8421. We just add 3 on 8421. Okay? Or we add 3 on the decimal before we convert it using 8421. So decimal 0 plus 3, code it using 8421. So we have 0011. Code decimal 4 using excess 3. 4 plus 3 is 7. Using 8421, we have 0111. Okay? And for 84 minus 2 minus 1, to get 5, we need to add 8, -2, and -1. So we have 1011. Okay? But in case in a binary code, we have two possible patterns. Okay? So we just need one pattern. Okay? From the two patterns in case we have more than one patterns that could represent a certain value. If that's the case, just choose one. Okay? And it will give us the correct coding. Okay? So last example, gray code. This is a non-weighted code. So if you going to analyze this, somehow there's no rule. Okay? But in reality, there is one rule when we create our own gray code. This is just one of the example of gray code. You could change it, alter it. Okay, no problem with it. The only rule with gray code is only one bit should change from one value to the next higher value. So for example, we start with decimal 0 equivalent to 000. Okay, we don't care which value will be changed as long as only one value will become 1. Okay, so in this example, this position from 0 to 1, only one bit should change. Okay, from 1 to 2, this position change. Okay, from 0 to 1. From 2 to 3, this position change from 0 to 1. Again, there is no rule which position will change as long as only a bit change its value, and there's no repeating pattern. Okay, so let's go back. 3, 4. This is the value that change. Then 4, 5, only one bit. This position. 5, 6, 6, 7, 7, 8, and 8, 9. So one bit change from one position, one value to the next higher value, and no repeating pattern for gray code. Okay, don't forget that. So let's have an example. So given 4, 3, 2, 1, So using 8421 notation, we're going to use 4 bits to represent each digit in decimal. So this will be the result. So 4 will be represented by 0100, 3 represented by 0011, 2 represented by 0010, and 1 represented by 0001. Okay? How about if you're going to use excess 3 to represent 4321? So we just add 3 on each digit. So 4 plus 3, 7. 3 plus 3, 6. 2 plus 3, 5. 1 plus 3 is 4. And the sum will be used for our coding using 8421 notation. So this will be the result. And in case we are using 84 minus 2 minus 1, so to get 4 from here, just activate this position. While 3, subtract 1 from 4, 2, subtract 2 from 4, and 1, subtract 2 and 1 to 4. So this will be the code. Okay? And for the gray code using based on the table, this will be the pattern.